So let's start with a new exercise 6D. Let's read the question. The sum S of n successive odd numbers starting from 3 is given by the relation S is equal to n times n plus 2. So as per the question, the sum of n digits or n numbers, n odd numbers is given by S is equal to n times n plus 2. Find n if the sum is 168. So that's simple. Sum is given as 168 and we need to find the value of n. And this becomes a quadratic equation. 168 is equal to n square plus 2n, which means if I take 168 on the other side, this becomes n square plus 2n minus 168 is equal to 0. So I need to find factors of negative 168, the sum of which should be plus 2. So let's do prime factorization. This is divisible by 7. 7 into 2, 14, 24. 2 times 12. I think I've got my answer. This is 14 into 12, which will give me 168, and if I subtract them, they'll give me 2n as well. So it'll be n square minus 12n plus 14n minus 168 is equal to 0. Let's club this together. N times n minus 12 plus 14 times n minus 12 is equal to 0, which is n minus 12 times n plus 14 is equal to 0, which means n is equal to 12 or n is equal to negative 14. Now since number of digits cannot be negative, since some number of numbers or some number of terms can't be negative, therefore n is equal to 12. Let's read our question. It says determine the value of n. So n is equal to 12. Right. Let's move on. Let's solve the next one. Question number 3. Question 3 says the product of the digits of a 2-digit number is 24. So it's a 2-digit number, which means there is a tens digit and a unit digit. So let the tens digit be x and the unit digit be y. Let tens digit be x and unit digit be y. Perfect. Now let's read the next part of the question. If its unit, the product of the digits is 24, which means x into y is given to be 24. Okay, let's read the second part of the question. If the units digit exceeds twice the tens digit by 2. Okay, so it says unit is equal to 2 times tens digit plus 2. Exceeds meaning add. So let's put the values. Unit digit is y is equal to 2x plus 2. That was my first equation. This is my second equation. Let's see if I can substitute something somewhere. So my first equation will give me y is equal to 24 upon x. So let's put this in the second equation. So put y is equal to 24 upon x in equation 2, and let's see what I get. So 24 upon x is equal to 2x plus 2. Let's cross multiply. This will give me 24 is equal to 2x square plus 2x. Let's take 24 on the other side. This gives me 2x square plus 2x minus 24 is equal to 0. Anything common? Yes, 2 is common through all these numbers. So let's divide the whole both sides by 2. X square plus x minus 12 is equal to 0. I need to find factors of negative 12, the sum of which is 1 plus 1. This one's simple. This is 4 and 3. Right? Negative 12 will be equal to negative 3 multiplied with 4. So x square minus 3x plus 4x minus 12 is equal to 0. Group this together. X times x minus 3 plus 4 times x minus 3 is equal to 0, which means x minus 3 times x plus 4 is equal to 0, which means x is equal to 3 or x is equal to negative 4. Now since the number is not given to be a negative number, so this is not possible. So put x is equal to 3 in equation 2 and I get y is equal to 2 into 3 plus 2, which is 8. Let's read the question. If the question says find the number, therefore the number is x and y, so that's 38. Perfect. Let's move on to the next question. Question number 5. Question 5 says 1 year ago, a man was 8 times as old as his son. Now his age is equal to the square of his son's age. So there are two time frames given. One is today and the other one is 1 year ago. So I prefer to make a small table. It helps me understand what we are talking about. And there are two people given. That's a wrong one. There are two people given. The first one is the man and the other one is the son. So let the man's age today be x and the son's age today be y. 1 year ago, his age was x minus 1 and the son's age was y minus 1. Now let's see the relationships which are given. 1 year ago, a man was 8 times as old as his son. So 1 year ago, so man, which means x minus 1 was 8 times as old as his son, which is y minus 1. That's the first one that we have. And is there anything else given? Now his age is equal to the square of his son's age. So now, which is today, his age, which is man's age, is equal to the square of his son's age, which means y square. So this is my first equation. This is my second equation. I think I should put second in one. So put x is equal to y square in my first equation. And let's see how it works. So let me erase this for now. Perfect. So let's move on. So if I put x is equal to y square, I get y square minus 1 is equal to 8 times y minus 1. Perfect. So let's open this. Y square minus 1 is equal to 8y minus 8. Let's take both these terms on the other side. So y square minus 8y minus 1 plus 8 is equal to 0. Y square minus 8y plus 7 is equal to 0. I need to find factors of plus 7, the sum of which will be negative 8. This one's also very simple. So this is 7 can be written as negative 1 multiplied with negative 7. Perfect. And the sum of this will be negative 8. So y square minus y minus 7y plus 7 is equal to 0. Group them together. Y times y minus 1 minus 7 times y minus 1 is equal to 0. Y minus 1, y minus 7 is equal to 0. Y is equal to 1 or y is equal to 7. So there are two possibilities of the son's age. Y is equal to 1 and y is equal to 7. So let's look at both the options. When y is equal to 1, x will be equal to y square, which is equal to 1, which means the father and the son are of the same age, which is ridiculous, which is scientifically, biologically not possible. So let's write the reason. Since the age of son and father can't be the same, therefore y is equal to 1 is not possible. So then I'm left with, therefore y is equal to 7, which means x is equal to y square, which is 49. Perfect. So let's read the question. What do they want me to find? Find their present ages. Therefore son's present age is equal to 7 years. We're writing the unit mandatory and important, and father's present age is equal to 49 years. Perfect. Now let's move on to the next question. What does the next question say? Next question is question number 7. Question 7 says the speed of a boat in still water is 15 km per hour. also the different kind of a question. It has still water. I'm assuming next part will be uphill or upstream and downstream. Let's see. The speed of a boat in still water is 15 kilometer per hour. So let's write this down. Speed in still water is equal to 15 kilometer per hour. Next, read the next line. It can go 30 kilometer upstream and return downstream to the original point in 4 hours 30 minutes. Find the speed of the stream. So we don't know the speed of the stream, which means when you're going upstream, you're going against the speed of the stream, and when you're going downstream, you're going along with the speed of the stream, which means let speed of stream be x kilometer per hour. So speed of boat upstream, which means when it's going against the speed of the stream, it will be 15 minus x kilometer per hour, and when it is going downstream, which means speed of boat downstream, it will be speed of boat plus speed of the stream, which means 15 plus x kilometer per hour. Perfect. So I have the basic question now. Let's read and let's solve what I need to solve now. So let's read. It says anything else given? It says it travels a distance of 30 kilometer upstream and 30 kilometer downstream to the original point in 4 hours. So total time is 4 hours 30 minutes. Since the speed is given in hour, I should convert this into hour, which means 4.5 hours, which means 9/2 hour. Perfect. And I also know that speed is equal to distance upon time, and in this case time is given, so time will be equal to distance upon stream. So time for upstream will be equal to distance traveled, which is 30 kilometer, and the upstream speed is 15 minus x, and the time for downstream will be equal to distance traveled, which is 30, and the speed is 15 plus x, and the relationship given is time upstream plus time downstream is given equal to 9/2. So let's substitute 30 upon 15 minus x plus 30 upon 15 plus x is given equal to 9/2. So now I need to solve this equation. Let's divide both sides by 30. So that will help me remove this number from here. If I divide the first term by 30, it becomes 1 upon 15 minus x, plus the second term becomes 1 upon 15 plus x, and this becomes 9 upon 30. So 9 upon 2 into 30, which is 310, 3. Let's take the LCM. So this will be 15 plus x plus 15 minus x upon 15 minus x multiplied with 15 plus x, and on the right hand side I am left with 3 upon 20. Negative x and plus x gets cancelled. Here it is 30. This is a minus b into a plus b, which is a square minus b square. 15 square 225 minus x square is equal to 3 upon 20. Let's cross multiply. This is 630 into 20, and this is 3 into 225. That's 675 minus 3x square. Let's take these two elements on this side because I want to keep my x square as positive. So 3x square is equal to 675 minus 600, which means 3x square is equal to 75. X square is equal to 25. Therefore x is equal to plus minus 5 kilometer per hour. Since we're talking about the speed as of a stream, then it cannot be negative, so we are left with 5 kilometer per hour. Let's read the question and see what they want us to find. As for the question, they want us to find the speed. So the speed of the therefore speed of stream is 5 km per hour. Thank you.